Well, if there aren't any questions on that, then I'm going to move over to the WRAP tool. Now, the WRAP tool is a watershed assessment tool at erams.com/WRAP that was developed jointly with CDPHE and a Clean Nutrient Center project here at CSU to do watershed scale assessment of at-risk watersheds. So you can sit down and compare a dozen different watersheds at different scales. You can compare a HUC 8 to a HUC 12 and start getting an understanding of which one's more vulnerable to this, which one has this data, and which one's in those sort of violations. So again, you're on the standard eRAMS page. We're going to zoom into Fort Collins again. Once we're in Fort Collins, the first thing that you have to do with the WRAP tool is specify your area of interest, your watershed boundary. And you can do this in a dozen different ways. If you want to trace out that I'm interested in this particular section of Fort Collins over here, you can draw a polygon, and then it'll ask you to name it. Or I could sit down and say I just want to look at a rectangle, make it nice and simple. Or you can also analyze layers, GIS polygon layers that you've uploaded. But because I'm on the public side, I haven't uploaded any layers, but I could analyze an uploaded layer here. So if you knew that your area of interest was this particular watershed that's not really a HUC 12 and it's not really a HUC 10, but it's over here and I actually have the shapefile for it, you could hop over here to the map tab, upload that layer, and then choose it here. And if you could choose a single polygon inside of that shapefile, or you could choose the whole shapefile. You can also use a known boundary to examine data at a county level or a watershed scale level. So I'm going to do the watershed scale level and look at the city of Fort Collins, HUC 12 here in Fort Collins. So you notice it goes out and grabs the watershed boundary for that particular watershed. Any questions on how to select a watershed with the WRAP tool? Okay, once you have your area of interest selected, you hop over to the next thing, which is you select the data that you're interested in summarizing. And there's all sorts of data, and it's summarized by category. So we've got climate and snowpack data, we've got environmental data, we've got hydrology stream data, all the way down to land surface and some others like confined animal treatment locations. And if you ever are interested what these acronyms are, we've got little nice tooltips that explain that PRISM is the Parameter Elevation Regression on Independent Slope Model, which is a climate regression data set. And you can also follow this data info link that'll summarize this is what PRISM is, this is what it covers. It's the lower 48 states, as opposed to NOAA covers all of the United States, as opposed to SNOTEL here only covers just the western states, because there's no SNOTEL monitoring sites in the plains because there's no persistent snowpack there. And there's all sorts of links off it to their actual websites if you want to go look at the data directly from them. And that's available for each one of these different categories. So if you want to sit down and look at just the environmental data, or if you want to go down and look at the hydrography, or if you want to go all the way over to aquifer extent down in the groundwater section, we've got those summaries for all of the different data sources. But I'm going to go through and pick one of the climate monitoring data sets, this NOAA GHC&D, which is joint between NCDC and NOAA as far as climate monitoring sites. We also have stream discharge. We also have the EPA 303D impaired water bodies list pulled in here, as well as the water body classification codes as far as what is their classified use. Is it recreation? Is it public contact 1? Is it fishing? Is it all of those? We also have the Surco soil data, so you can look at the different classifications, some of the classifications within that database as far as drainage class, how quickly those soils drain. The hydrologic group, that's really useful for watershed modeling as far as is this an A soil, is this a B soil, or the runoff potential. We also have the groundwater as well as some other land surface data sets, including impervious surface from the NLCD. So you can get a sense of what is the general imperviousness in this area that's preventing the runoff from infiltrating. Or if I want to look at land use, you can specify, you can look at a single year of land use, either from the USDA or from the USGS. Those are their two databases. You can look at a single year, or you can pick the trend one, which will compare multiple years next to each other to see how the land use has changed over time. You can also interact with U.S. Census data from 2000 to 2010, and you can also interact with some Reg 85 data that's Colorado-specific, some confined animal feeding operations data, which unfortunately is not in this particular watershed, so I won't check that one. That's only Colorado-specific, but again, all of these specify what the coverage is for these different layers at the moment. And once you've selected all the different data sources that you're interested in, you can hop over here to generate the report. And what it's going to do is it's going to open a brand new website and start loading up all the different data sources. Now, I've already run this just to save some time, but basically it gives you the title of what it is. It tells you what you analyze. This is the title of the area you analyzed. It gives you the area of that watershed that you're looking at, when you ran the report, and then it gives you a nice little table of contents for all the different data sources you included in there, as well as this quick one-off summary for indicators of watershed health. Those are just generalized indicators that at a glance you can look at a watershed and say, okay, it has 10% natural land cover, it has 80% natural land cover, the population is this, the density is this, just to get a general sense of how you can compare some of these watersheds to each other. So you can see over time with the natural land cover trends that back in 2008, there was more natural land cover. There was 76%. Today, there's only 65%. So in this particular watershed, over those years, we've lost 10% of the quote-unquote natural land cover. And then for each one of these data sections, you've got an interactive map that summarizes what the data is. So in this case, it's all the different NOAA, GHC, and D monitoring stations. And this is still an interactive graph. And you can zoom in and start looking at all the different names of all the different stations. And then it's got a time series of all of that data. One of the really new features that we just added in here is you can actually start downloading all this. You can get that data file. You can get that shape file of those monitoring locations. You can get that here in this data file, as well as a link out to the metadata that explains what PRISM is, what NOAA GHC and D is, and some of that stuff. That's more of like the ArcGIS style metadata. Any questions on that so far? Okay, so like I said, we've got the EPA 303D data that's highlighted by the different subcatchments of the water body, of the, I think these are WBID codes, as far as whether it's the main stem versus a tributary versus that tributary. And then it summarizes the impairments by that WBID. So, and tells you how many segments are inside of there. You can see that it's got a temperature impairment. You can tell that it has a copper impairment. And you can tell which reach codes are there. And it also has a link here out to the actual EPA database, their Attains water quality database, that houses all of this data. So you can get the summary here, or you can hop over here and get a real similar look. It's still temperature and mercury. And this is for each one of those different segments. So it's got a nice little list of all that stuff. And then the same thing for the water body classification code. So it's again summarized by the section of the watershed that it's in. And then it says whether it's agricultural, whether it's domestic, whether it's primary contact recreation, whether it's aquatic cold life versus aquatic warm life. And it's got that same summary and it's the same link out to the database. The next one that's up is we've got a soil summary. So you've got this nice little interactive summary of all the different soil classifications that are in there as far as their drainage types. So you can see that most of the soil in this particular watershed is well drained. There's some that's poorly drained and some very poorly drained. Of course, the little missing spots are typically water bodies that you don't have any soil data. No one sampled the soil underneath that reservoir. We've also got those imperviousness trends that I was telling you about, so you can sit down and look at, back in 2001, we had a roughly 7.1% imperviousness average for this entire watershed. So you can actually go down and see the imperviousness level on a scale from 0 to 100 of what sort of level of impervious is there. Is it all concrete, or is it somewhat concrete, or is it roofs, or is it gravel? kind of thing. That's what the imperviousness gets at. And you can see over time that that imperviousness has increased. That makes sense. The city's grown. They built more roads. They built more houses. There's just more imperviousness in the same location. And then you get a very similar summary with the land use that compares it over time, that you had that original 76% natural land cover all the way down to today's 65% natural land cover. And you can go in and examine all the different land use codes in here as far as if it's alfalfa or if it's urban developed open space or urban developed high intensity. And it also explains what's going on as far as how do we define natural space versus non-natural areas based on land cover. And again, you can download all of these maps as a nice little summary here if you want to have those rasters to interact with on your local computer for your local analysis. We also have the population data pulled from U.S. Census. So we've got the different blocks labeled out here, and it'll hover over and tell you the population density of those various blocks. And they're color-coded accordingly, and you can see the population growth over time between those two censuses. We're working to add the future estimated 2016 population as well as the 1990 and 1980 censuses. So we're working to expand this into more census data so you can get a more general estimate of decadal changes in the watershed over time. As I said, there's no CAFO information here. And then you also get a nice summary of the Reg 85 monitored wastewater treatment plants by the state. That's all stored in STORAD data that are summarized by the facility. Say that again?
What's Reg 85, Tyler?
Reg 85 is the state of Colorado regulations that dictates how to monitor and enforce and what water quality standards are there for wastewater treatment plants.
Okay, thank you.
No, that's fine. That's a good question. So this pulls all of those Reg 85 monitored wastewater quality plant data as far as their actual discharge location, as far as their upstream, downstream monitoring locations, and summarizes it per facility based on their station ID, and this is their permit number, of course, with the state, and then what sort of treatment type they have at that facility and what sort of core process, and then what their average discharge is. So if you notice way back up at the top, one of the indicators of watershed health was the total wastewater plant discharge for this watershed. So we can tell that 14.96 million gallons per day comes from wastewater treatment plants on an annual average basis. So this is annual average flow of observed data. This is not their permitted. This isn't their maximum permitted number. This is the actual observed data. Over the years, the Box Elder Sanitation District has discharged roughly 2.5 million gallons per day on average in the recent past for 2015's data. That's pretty much the RAP tool as far as the report summary. This is all interactive, so some of these longer ones, like these with the EPA 305B classification codes, if you want to scroll through this a little bit better, you can collapse that statistic summary down there or re-expand it. You can access the metadata. You can download the shape files themselves. You can download the data themselves. All of the graphs that are in here are interactive to the point that you can also just straight download the CSV data for that graph. You can download the pie chart. You can download it as an image if you want to put it in a report, or you could print this entire report yourself. We can also store those reports by giving it a unique ID code and saving it in our database. We're open to discussing whether the 24 hours is sufficient for what people want to store it as, but we at least have the capacity to store these reports over time.